Welcome back. We're on the back of Form A, and now we're on number 7. So here we have y equals 3 times the cosecant of x. So now we finally have some numbers going on, which is going to change how our graph looks from our function, our parent function. So we should be still using our notes to help us with this. So we have cosecant, which means it is going to be the one with the upside, upwards facing and downwards facing u's. So that means we have 2 pi divided by b for our period. So let's keep working on this. Nothing easy for cosecant for domain or range, so we'll come back to that later. And then amplitude is what we can start at right away. So our amplitude, we steal our a, so that would be 3. Our period, as I said, was 2 pi divided by b. Here our b is 1, so we get 2 pi. Phase shift, nothing. Vertical shift, nothing. So then the only change we have is that our amplitude is increased. So we can still choose our normal x-axis and y-axis right in the middle of our graph, and then we can start graphing. So for our cosecant, we have, instead of the first u being centered on the y-axis, it's the first asymptote is centered on the y-axis. So when we figure out what our tick mark should be, we do want 2 full cycles, but then one cycle will be completely on the right and one cycle will be completely on the left. So we just have to fit this period of 2 pi on the right-hand side of the graph. I'm just going to be lazy as I have been and just label every red line pi. And then do the same thing on the left with negative. Alright. So now we can start. We also need our amplitude. So I've always just said, especially since there's no vertical shifts yet, we can just put halfway mark between our x-axis and the top of the graph and just put our amplitude there. And then we have positive and negative version. So we can put our first vertical asymptote, and I said it's going to be on our y-axis because that's what our cosecant always looks like. And then we can go to the end of our period, which will be all the way at 2 pi because our period is still 2 pi. So we just go over. Since it's cosecant, we also need another vertical asymptote right smack dab in the middle of our period. So those are our vertical asymptotes for our first cycle, and then we can just start drawing our dots next. So we go halfway in between 2 of our vertical asymptotes, and we always start with the upwards facing u first. Here we just go up the amplitude in the middle, and then draw our u so it goes through that. On the other one, we go down in amplitude, right smack dab in the middle of our 2 vertical asymptotes, and then draw our u that goes through that. So that's how we draw one cycle, and then we can draw the other cycle on the left. And then we can start, so immediately to the left of the y-axis would be the downwards facing u. And then again to the left, now we do our upwards facing u. So now we have 2 full cycles because we have upwards u, downwards u, and then upwards u, downwards u. So let's go back and try to fill in the rest of our table. So range is the easiest one to do out of the 3, and that would be from negative infinity. Here we do d minus the amplitude, so 0 minus 3, so negative 3. Union, then we pick back up at d plus a, so positive 3, positive infinity. Asymptote would be next. So our common difference is half the period. So that's pi, so we have pi times k, which just means that's our repetition part. K can be any whole number, positive or negative. We pick a vertical asymptote. This one right here is the easiest because it's just 0. So we do pi times k plus 0, which is just pi k. So domain is the same thing as asymptote, just with a not equal sign. So we have x cannot be pi times any whole number, positive or negative. And that would be how we finish our graph. So if we move on to number 8, now we get a cotangent. Alright, cotangent, if we're looking at this, again, it's just kind of like cosecant, where we still have the same curves, but our first vertical asymptote is centered at the y-axis instead of our first u or our first s curve. So we're looking at this. Let's start filling out our information. Domain and range are a little bit tricky, but amplitude is easy, and it's 4 since our a is 4. Our period is, we don't have a b, well, it's 1. So for cotangent, tangent and cotangent are the weird ones. We do pi divided by b. So here our period is just going to be pi, since we don't have anything inside the parentheses next to the x. Phase shift, again, nothing. Vertical shift, nothing. And then now we can start graphing. So we just have an amplitude change. So now we can go in, draw the same set of axes we've always been drawing. We don't really need to move them around. Tick marks for y-axis, we always just do amplitude, especially easy here since we don't have a vertical shift. Same numbers on the top and the bottom. And now for the x-axis, we need 2 full periods. Our periods are quite small, they're only pi. So we can just go pi to the right, and then pi to the left. So now we can start graphing. Alright. So when we're looking at this, we said for cotangent, our first vertical asymptote starts at the y-axis. So let me draw that in there. Then we draw our second vertical asymptote, which I always do at the end of the period, which is just be pi away. And to draw our cotangent curves, tangent is positive, like what I just drew. Alright, t and positive look like the same symbol. And then cotangent would be negative, kind of negative version of that. And the parent function scooted over just a little bit. So we still go over our first dot that we draw is in the middle of our period, so in the middle of our 2 vertical asymptotes. And it will be right on the x-axis since there's no vertical shift. And then this is where the difference between cotangent and tangent exists. So if I go to the right, I'm going to go down in amplitude. If I go to the left, I'm going to go up in amplitude. So this would be what the cotangent curve would look like. All right, and it's slowly approaching those asymptotes, so do not cross it. And then we can draw our second period over on the left. And again, middle dot goes in the middle of our vertical asymptotes. If I go to the right a quarter of our period, I go down in amplitude. If I go to the left a quarter of the period, I go up in amplitude. So notice how our graphs kind of look similar, but I'm just kind of changing the labels on the axes to make it fit our actual function. So range, oh, we could have done this one right away. Range for tangent and cotangent are always just all real numbers. Asymptote, this one's similar to the one that we just did for number 7. The common difference is the period, so here that's pi times k. And then we would put in our first vertical asymptote, which here is 0. So I don't need to add or subtract anything, and then that would be x equals. For domain, it's the same thing, but just x cannot equal anywhere where we have a vertical asymptote. So x cannot equal pi times k. Alright, moving on to our last problem on this worksheet is finally one that has a little bit of complexity going on in it. Alright, we have a secant function, but we have -2 times secant of x divided by 3. So we finally have a couple things going on at once. So let's jump right down to amplitude. Our amplitude would just be 2 here. We just take the absolute value of 2. We'll talk about what to do with that negative in a second. The period we have b equals 1/3. So for secant, we do 2 pi divided by b. So here we would get 6 pi. Phase shift, still nothing. Vertical shift, still nothing, just like our other examples. So now we can just at least figure out what our axes should look like, and then we can figure out this other information. So since we're just changing around our period and the amplitude, we can just draw our normal axes. Amplitude, kind of general rules, just always put it right in the middle of our y-axis. So we have 2 on the top, -2 on the bottom. And now we need to figure out our tick marks on the x-axis. For all of our functions, we always break our period into quarters. This one's going to be a bit tricky. Since we have 6 pi, if we divide that by 4, we're going to get a fraction. No way around that. So the way we can avoid dealing with that is just not to label the quarter marks. So if we put our 6 pi here, the halfway mark of that would be 3 pi. And even though we'll use it, the quarter marks, to graph, we don't need to label it, so we don't need to actually figure out what it is. So we get -6 pi on the left, which is the full period, and then the half period, which would be -3 pi. Alright, so now let's start talking about what the what the secant curve looks like. Secant, we have a u, as we talked about for number 5. We started with secant there. So when we look at this, same thing that we did, we're changing our period, we're changing our amplitude, but our first asymptote is still going to go not on the y-axis, but a little bit to the left of it. So technically it's going a quarter of the period to the left. So we could have found it would be -3 pi over 2, but we can just put it halfway from 0 to -3 pi, and that means we would go a quarter, 2 quarters, 3 quarters, 4 quarters to the end of our period, which would be halfway in between 3 pi and 6 pi. And then we draw, for secant and cosecant, we always draw another vertical asymptote at the halfway mark of our period. So that's how we would draw our vertical asymptotes for one cycle. And then, just as usual, we go halfway in between our vertical asymptotes and go up to the amplitude. That's how we would do it. But since we have this negative in front of the 2, our first u, which should be upwards facing if we had a positive a, but now since we have a negative a, it's going to be down at -2. So our first u that we draw is actually going to be downwards facing, and that's where this negative comes into play. So the next one we draw, we go to the middle of our next vertical asymptotes, and we actually go up an amplitude, which is different because that 2 is negative. So now if I wanted to draw a second cycle, I have more space on the left, so I would start at my leftmost vertical asymptote, go over an entire period, which would be just to the left of -6 pi, and then draw another vertical asymptote halfway in between those two, which would be halfway in between -3 and -6 pi, which would technically be -9 pi over 2. So when we look at this, we can just look back to our first cycle that we drew. So if we had a downwards facing u, the next one immediately to the left of it would be upwards facing u, so I go up an amplitude and then draw a u through that dot, and then again I have to do the next one as a downwards facing u, so that way we have a nice looking pattern. We go downwards facing u all the way to the left, then upwards facing, then downwards facing, then upwards facing, so there's that repetition. So now we can look back at our range. So our range would be -infinity to -2, and then we would pick back up at 2, and then go to +infinity. Vertical asymptotes are next, so we would do x equals, find our common difference, which for secant and cosecant, that's half the period. Our period was 6 pi, so our common difference was 3 pi. And that's the distance between our vertical asymptotes. And then we put our k next to that. And then we can pick any vertical asymptote, and that's the number that we add here. I always like adding the one that I started with first, which is the one I just circled, which here is the only time we need to write a fraction, would be -3 pi over 2. So then if I go up to domain, same thing, but now can't equal where our vertical asymptotes are. So 3 pi k minus 3 pi over 2. Alright, so that finishes the worksheet. On Monday, you'll be trying to explain this to somebody who had the opposite version of you. So hopefully there's enough people. You guys all looked at amplitudes. The other group is going to be looking at amplitudes and period changes and even a phase shift. So we're going to be able to compare our answers and learn from each other. So I'll see you tomorrow in class on Monday.